In this lesson, we are solving systems of equations using the substitution method. Here are some steps to follow. Step 1, we need to solve for one variable in one of the equations. So in our system, we are going to have two equations. So this means that one of the equations needs to be in the form y equals an expression or x equals an expression. So if one of the equations is not in this form, then we would have to make one of the equations be in this form. Step 2 is to substitute this expression into the other equation. Then we need to solve to find the value of one variable. And then we would substitute that value of the variable into one of the equations. We would then solve to find the value of the other variable. And lastly, we would write the solution as an ordered pair. And just as a side note, it's always a good idea to check to make sure that the solution you came up with is actually a solution to the system. So by substituting the x and y value that you got for the solution into both of the equations in your system to make sure that they're true statements. So let's look at some examples. If we have the system y equals 3x minus 6 and 4x plus y equals 1, our first step says to solve for one variable in one of the equations. So one of our equations needs to either be in y equals or x equals. So in looking at our two equations, we can see that this one has y equals and then an expression 3x minus 6. So that first piece of having that one of the variables isolated as y equals or x equals, we have with that first equation in our system. So our first step is actually already done for us. So then we look at step 2 and it says substitute this expression into the other equation. So now we are going to look at the equation where we have the y equals, and we're going to look at that expression, that 3x minus 6, and we are going to substitute that expression into the other equation. So since our 3x minus 6, it says is equal to y, then we can substitute that expression into y for the other equation. So let's see what that will look like. So just recall here that we have our coefficient of our y is 1. So if we had a coefficient of 2 or another value, that would impact how we substitute that expression in. So just be aware that our coefficient of our y here is 1. So now we are going to substitute that expression that we have for y, that 3x minus 6, into the second equation in for y. So the first part of the equation is going to stay the same. So we're going to have our 4x plus our y now is we're going to have that coefficient of 1, and we have the y is now 3x minus 6. And notice how that whole expression is in parentheses, which is going to be an important piece as we progress through these examples, and we're going to have to distribute that coefficient of y here. And so then also recalling that that equation is set equal to 1. So the only thing in that second equation that we're changing is we're taking that expression 3x minus 6 and substituting it in for y. Everything else stays the same. So then in our next step, we would distribute this 1 through to both terms in the parentheses. So we would have 4x plus 3x minus 6 equals 1. We can combine our like terms, so we would have 7x minus 6 equals 1. We can add 6 to both sides of the equation. So we would have 7x equals 7. And to isolate x, we would divide both sides by 7, so we would get our x value to be 1. So now we have completed our third step in our steps to follow, and now we have solved to find the value of one of the variables. So step 4 says to substitute the value of the variable into an equation. So now we are going to use the value that we got for x, which is 1, and substitute that into one of the equations. So using that first equation in our system, y equals 3x minus 6, we are going to now use our x value of 1 and substitute that into that equation. So when we do that, it would look like y equals 3 times 1 minus 6. So then we would just simplify that expression. So 3 times 1 is 3, and 3 minus 6 is negative 3. So now we have solved to find the value of the other variable. So we have our value of 1 for x and our y value of negative 3 for y. So then we would write our solution as an ordered pair. So our x value written first and our y value last. So the ordered pair 1, negative 3. And like I said earlier, it is always a good habit to double check your solution to make sure it really is a solution to the system. Let's look at the system. Negative 7x minus 3y equals 22, and x equals negative 4y plus 4. So recall our first step says to solve for one variable in one of the equations, so that one of the equations is y equals or x equals. So looking at this first equation, that equation is actually in standard form, but if we look at the second equation, we can see that we have x equals and an expression. So our first step is already done for us by that second equation being solved for x already. So now we are going to use the expression negative 4y plus 4, which in this equation states that this is equivalent to x, and so now we can substitute that in for x in the other equation. So using that first equation, negative 7x minus 3y equals 22, we are going to now replace the x in that equation with this expression, negative 4y plus 4. Remember that negative 7 and x are being multiplied together, so you have to surround this expression with parentheses because we are going to end up distributing that negative 7 through. So when that is substituted in, we would have negative 7 and in parentheses negative 4y plus 4 and close our parentheses for that expression, and then continue writing the rest of the equation, which is minus 3y equals 22. So once again, the only thing that we're changing in this equation is we're substituting this expression in for x. So then we have now substituted that expression in, and now we would need to distribute. So negative 7 times negative 4y and negative 7 times a positive 4. So we would have 28y minus 28, and then bring down our minus 3y equals 22. We can combine our like terms, so 28y and minus 3y, so we would have 25y minus 28 equals 22. We would add 28 to both sides, and 25y equals 50. So we would divide both sides by 25, so y equals 2. So now we have solved to find the value of one of the variables. So now we are going to substitute our value that we have for y into one of the equations. So using the equation x equals negative 4y plus 4, we are going to substitute the value of y, which is 2 in this case, into the equation for y. So when we do that, we would have x equals negative 4 times 2 plus 4. So now we have substituted that value into the equation, and now we are going to simplify. So negative 4 times 2 is negative 8, and so we would have x equals negative 8 plus 4, and simplify that, so x equals negative 4. So now we have solved to find the value of the other variable, and we would write our solution as an ordered pair. So our x value in this case was -4, and our y value is 2. All right, let's look at another example. If we have the system y equals -4x minus 16 and y equals 3x minus 2. So in our first step, it says solve for one variable in one of the equations. So in this case, we can see that we have y equals for our first equation, and we also have y equals for our second equation. So in this situation, we can just take our first expression that y is equal to, so that -4x minus 16, and our second expression that y is equal to, that 3x minus 2, and we can set them equal to each other because y would be equal to y. And if both of those expressions are stated above as being equal to y, then we can just set them equal to each other. So our equation, when we substitute those values in, would be -4x minus 16 equals 3x minus 2. And then we would just solve the equation for x. So recall here that there are several different steps you could do first. So in this situation, I just added 4x to both sides. So then I have -16 equals 7x minus 2. I'd add 2 to both sides. -14 equals 7x. If we were to divide both sides by 7, then x would equal -2. So now using that value of x that we have, which in this case was -2, I can substitute it into one of the equations. So I just chose the first equation, so y equals -4x minus 16, and I'm going to substitute my value of x as -2 into that equation. So y equals -4 times -2 minus 16. So in simplifying, -4 times -2 is a positive 8. So y equals 8 minus 16. And simplify that further. So y equals -8. So writing this as an ordered pair, our x value is -2 and a y value is -8. So now I want you to pause the video and work out these practice problems. When you are finished, push play to check your answers. So here are 3 different systems of equations that I want you to practice on your own using the substitution method. So make sure that you pause the video now, and when you push play, the answers will be revealed. Okay, let's see how you did. So here are the solutions to each system. So the solution for the first system was -6, -2. The solution for this system was 7, -3. And the solution for this system is 4, 6. So if you have any questions on this, make sure that you pause the video and ask for help, or rewind a little bit and see if you can figure out where you might have made a mistake.